Any company updates?
Tinybox Reds are selling. We sold like 4 of them. We haven't actually shipped any yet. We got to make sure they ship today.
Not today.
Yeah, we got to make sure they ship today. We are hitting some. There's a little bit of instability, and
Stable now.
it's stable now. What was it?
I think it was just power.
Did you throttle them?
Yeah.
Hmm.
The throttle a little bit seems stable. But also didn't throttle a box, and that also passed.
I see.
So seems to be some variance between boxes.
Yeah. I mean, the AMD GPUs might have really high transients. We just might need to clip the transients on them. But I mean, yeah, I have one here. And like, look, again, these things are like, we test them in really extreme cases. So they definitely do work. So yeah, Reds are going to ship soon. We got 2 orders for Blackwells. Those are also going to ship soon. We did our first testing with that. Everything looks good on that. I mean, those boxes have 2 power supplies, so you got plenty of headroom there. Yeah.
Cool. Okay. Moving on to training loop. I think I will focus on this this week. What's the current status on this? So when I tried training stuff, I hit the fault in my 350. I think other people also hit that.
The MMU fault, you mean?
Yeah.
I think a fix went in this morning. I'm not sure that that's everything.
Oh, okay.
Nimmeljan, you have more to say about that?
Actually, no. Yeah. I mean, we had some bug in our code base. I'm not sure that's related to the MMU fault. I haven't reproduced it since that.
Got it.
Yeah, so what I was doing this morning was I was trying to run a ring or reduce, and I hit the other thing that we discussed in the AMD channel, some of the intermediate number overflow that we also probably want to fix, as our thing would be pretty much hitting all the limits on the machine. Okay. And George, you mentioned another thing that's slow.
So yeah, I mean, if you think it would be helpful, I could work on this week. So basically what you want to do, it's the same way that we're going to split out the micro steps into their own JIT. So you really want to separate out like everything should be like really fuse optim. So you're doing the gradients, you're doing the gradient clipping in a way that's really slow and generates tons of kernels in the Llama trainer. So what you want to do is you want to basically concatenate all the gradients into one tensor, and then that single tensor can do the update. If it would help, I could write this, but I don't really know how I'd test it, is the problem.
I mean, if you think you can write it reasonably fast, I can test it.
Yeah, I'll spend the next 2 days on it. I think there's a few things that we might need to optimize too, because it is kind of like in the set assign kind of area. But like slice assign.
Mm-hmm.
But yeah, no, we want the micro step to compute the entire gradient, and then after we compute the gradient, like the optimizer should basically only be like 4 kernels.
Okay.
Which will have our kernels. Also, there's been a ton of progress on speed. Everything's about 3x faster now. If you try Stable Diffusion on your Mac, there's been a ton of progress on Python speed in the last 2 weeks.
Sounds good.
So yeah, I think we're good on. I don't think we need scan. I mean, we still want scan, but I don't think we need it to do 4 or 5B. 8B starts up pretty fast now, and 4 or 5B. Okay, it takes a minute to start. Great, it's an 11-day training run. Like that's fine.
Okay. How about the outer world range? Do we still want that?
I mean, we do, but I don't think we need it for the AMD contract.
Okay.
I think that now I fixed a lot of the stuff. So I fixed like all the n squared behavior too. So the 4 or 5B was particularly bad because there was n squared behavior on the layers. This was mostly in this tensor assign thing, and I fixed that last week. So the speeds are all reasonable now. Like the speeds are all within like they're the same as Torch basically. So yeah,
Sounds
sure.
good.
Scan would be great, but it's plenty good. And AP starts up really fast now.
That's good. Okay.
I mean, like
I would
15
I would test all these, see where we are, and probably need to really train something on a real machine and figure out if MMU fault or any driver issue.
Cool. Yeah, I'll work on that. I'll work on the training loop with like a built-in fuse optim. But yeah, I don't really know how to test it, but I'll just put it in a different file too. I'll make like a llama train.py and
Oh, okay. Sounds good.
yeah. I won't touch the other one because the other one's tested.
Okay. Yeah, no problem.
Cool.
Anything for flash attention?
Yeah, if you run on my PR, eval should work with flash attention. I couldn't actually get it to run because I hit the MMU fault too.
Is there any
Is that can you use the same flash attention on like smaller, I don't know, llama 3.py or stable diffusion? Does that work?
Yeah, it should work in Stable Diffusion too.
I mean,
It
yeah.
won't work in Llama 3 because that's variable shape.
Can you put it in tensor.py?
I thought about that, but it's very MI350 specific. If that's fine, we can put it in tensor.py.
Yeah, I think that's fine.
It also imports from extra.
Yeah, I think all these things are fine. If you
Okay.
get it with an mvar and it's just like the flash attention, just make it like FA equals 1 and
Okay.
yeah, FA equals 1 we'll use the fast scale dot product attention.
As long as it's not another. Oh, how long is this?
How long is what?
How big is this code?
Oh, I mean it'll just import it.
Yeah, that's fine, right? It's just a few lines.
Yeah, it's just a few lines in tensor.py.
Yeah, that's fine.
Not too much, yeah. Yeah, but it'll just run like fast scale dot product attention, and then we can test it in like stable diffusion and stuff too.
Yeah.
But stable diffusion is probably a good place to test it.
Okay. And this is forward.
Yeah, this is forward. Backwards is a little more complicated. There's some stuff that we have to save, and I'm not sure how to save stuff with the custom.
Yeah, I can show you how to do that. So you have 2 outputs from a kernel or 1 output from a kernel?
One kernel has one output, one kernel has 2 outputs.
2 outputs is that's tricky.
Yeah.
As long as you only have 1 output, you're fine.
See.
But even if you just want to save it, yeah, I mean, you just probably want to add like a context and just like create a tensor empty that it writes to, and then put that in the context for the backwards pass.
Yeah.
Like it'll be very explicit, but it should just work.
Because
right?
backwards there's a pre-kernel for backwards, and then there's, at least the way we're doing it, there's 2 kernels that actually compute the gradient.
2 kernels is no problem. It's just on the forward, when you have a kernel that has
Yeah.
2 outputs, it's difficult for us to compute the gradient because think of how it
Yeah.
flows from 2 places. So you want to avoid that.
Okay.
Yeah, so what I would do is if you just have like one thing that you want to save, I would just create an empty tensor, put that empty tensor in the forward, and then add that tensor to the callback.
Okay.
Like have the callback just do like functionals dot wraps, or not wraps, but you know the one where you like partial apply.
Yeah.
Functionals dot partial. You do functionals dot partial on the kernel, and then you can partially apply that empty tensor. And it'll be explicit, but it'll work.
I see. Okay.
Yeah.
Yeah, there's that, and then I need to fix the after end.
Yeah, it's not hard.
Yeah.
The after end thing's easy to fix, but do the first thing I would do is get it working in tensor.py, and let's get stable diffusion running on the MI350X with flash attention, because stable diffusion is a great test.
Yeah. Okay.
Sounds good. Move on to this.
I did merge some stuff for SKTT. Now it's fast. Last week it was very slow. That should be fixed with a split up per C graph. So if you run with viz equals 2, you can see the timeline of the waves and then instructions all folded nicely.
You know, I think there's been great improvements. It's getting kind of usable. We still got to do the like aggregate view. I think the aggregate view should just be on the click, and it should aggregate everything across all the waves.
I did that. It's slow. RGP limits to 60 waves.
Interesting. Wait, why is it slow?
It's slow to decode. Like it takes
Oh,
I don't know,
because you're
like a
only
minute to
decoding.
decode all the instructions. Yeah.
I see, because you're only decoding when you click on a wave. Okay, never mind. Don't do this. That's annoying.
I know, yeah. It's in the branch. I didn't merge it.
Yeah, I'm half tempted to rewrite SQTT trace decoder in Rust. Just get something insanely fast on there. That just like parses
Yeah.
these things, and yeah, I don't know. No, we shouldn't actually do it, but I think we have enough of it figured out now that we could switch to the non-AMD one. But we don't have it. It works for RDNA 4, but it doesn't work for CDNA. My reverse stuff.
Mm-hmm. I also get errors for RDNA4.
Do you?
Yeah, yesterday I got stuff for MD mat at UOP Matmol. That's like some offset didn't assert.
In SQTT parts equals 1.
Yeah.
Oh, post the way to reproduce that. I'll take a look at that. It's probably something simple. Because it is the same. It is the same thing. But yeah, no, I think yeah, this week let's do performance counters. I'm hoping performance counters are lightweight enough we could do them with viz equals 1.
Should be, yeah. I mean, like all of them have some overhead of flushing the buffer at the end of every kernel. But other than that, it's
What do you mean flushing the
tracing
buffer?
overhead. So after every kernel, you save the trace into a buffer from the GPU, copies out. I
Wait,
think that's how it works.
with just performance counters?
No, I mean we just treat every counter like
Oh yeah,
from
that's cheap. As long as we don't do
Yeah.
anything like clear the L2 or anything. Yeah, like reading 20 counters is going to be free basically.
It's not 20. I mean,
How many is it?
some of them are dependent on a counter, but some of them are like tracked per seamed. So a bunch of them
Some of them are what?
tracked per seamed, like per CU. I mean,
Oh,
like each
per
CU has its
CU.
own counter. Yeah.
Yeah, I mean, I guess we could also do, yeah, that's again, that's not that many. I don't know. But I would like some performance counters to work with viz equals 1. Like we should it'd be great if we could like just show like basic memory overheads with viz equals 1, as reported by the GPU. Kind of like what our bandwidths are to each like the L2 bandwidth, the L1 bandwidth, and the DRAM bandwidth.
Cool. Yeah. I'll work on that.
Cool.
Extract decode.
Yeah. So I merged. So I merged the minimal HAVC decoder for NV. So it's pretty slow without, so because it's not jittered right now. So the whole time is in scheduling right now.
What is why is it? I mean, we kind of need like a framework to deal with these kind of things. Like it's the same as the copy engine, right?
Kind of, yeah. I mean, yeah, it's not that hard to make the JIT. The only problem is that actually we need to clone after each JIT right now, so that's also kind of slow, or one wasteful copy, and it and like it has variable sized inputs to the JIT, like because the in buffer different sizes, like each chunk has different size.
Yeah, so the way that I would deal with that is I would just pass the entire video into the JIT and then put the offset and size in a variable.
Yeah.
I wouldn't worry about the clone thing on the output because like usually you're just gonna like do something with the frame. Like imagine basically the flow of like decode a frame, run a model, decode a frame, run a model kind of flow. So it's okay if it writes the frame into the same app. Oh, but I guess it's not because you need the history.
Yeah. It also will corrupt.
Yeah. Yeah, then what I would do, I would like pass in two tensors into the JIT, one that's the whole video and one that's the history tensor. Maybe like an offset into the history tensor too. And then a bunch of variables to deal with like where the frame is that you want to decode.
Yeah. I mean, for the history right now, like the solution I have is just to, like, we know the size of the history, like the maximum size of the history.
Yeah.
And it's like, so yeah, and just pass all of them the max size to the JIT. So it like capture all the tensors. Yeah,
But I see. So you're like passing the history tensors. I see. I should just read your code. Yeah, I mean that seems reasonable. But the way to deal with the variable size thing on the input is just to pass in two variables.
Yeah, okay. We'll do that. So currently
And
we also
then
yeah.
you think it's worth doing AMDs?
Yeah, I'll take a look into that. Yeah. I mean should be pretty easy to do. So I think it should be pretty easy to do like for the kernel driver. But for AM, like it's still like we need to enable this UVM, VCN, how it's called. VCN, yeah.
Got
So
it. Yeah.
yeah.
Just for the kernel driver would probably be fine. I just like the idea of whenever we're working on a new abstraction to have both AMD and NVIDIA, so we know like what we need to abstract and what we don't.
Yeah.
And I find always like doing one teaches me things about the other too. It's like, you know, NVIDIA has this weird stuff about the memory and the VCN or whatever they call it. I wonder if AMD has similar stuff. But yeah, absolute highest priority is any bugs on MI 350X, all those things. Yeah, if we could somehow reproduce the MMU fault, I think that's the highest priority stuff. But otherwise, yeah, I think good work on the HVAC decode, and let's find the right abstractions for it. Let's get it to be fast on the jet, and then let's try to convince Comma to use it.
I see
Yeah.
Heroes
Yeah.
Echo. You want to add something?
What do you say?
Oh, sorry.
Oh, I see Heroes on the code.
Yes, sir. I heard my name. What was your question?
We're building you an HVAC decoder. Do you want it?
Yeah, I saw it gets exactly the NVIDIA posted speed, so that's pretty good.
But we didn't specify if it was C2 or C3.
I guess.
It wasn't a bug. It was just the wrong video.
It's just the wrong video.
No, I think I posted the second one, which is
Yeah. Harold and I have a $50 bet about whether we're gonna get over 2,000 frames per second.
which was optimistic. You could double NVIDIA's performance.
All I said was that I don't think there was a bug. That I think it was actually correct, and it was.
Yeah, I mean it's still quite. I mean, it's faster than what we use, so it actually would be an improvement. But we actually don't get NVIDIA's posted numbers.
I mean, you should also be able to pretty easily, like, the idea here is that you'd want to move your segnet into Tinygrad too, and that the decode and segnet would be together very fast.
Yeah, I mean, yeah, that will be great. It's not trivial in our current setup to move everything from the decoder to the model runner without taking it off GPU. It'll require some really ugly code.
But yeah, it would be easy if all you had to do was throw in an HVAC and get segnet outputs out, right?
Yeah, exactly. It would be easier if Tinygrad handled all the GPU stuff, so then
Yeah.
we don't have to have like 4 libraries to keep stuff on the GPU.
Yeah. Do you have your latest Segnet Onyx somewhere?
I'll post it.
Cool.
Yeah, the only thing I wanted to show for, if you guys are open to this, is the if we can get the zero copy Qualcomm stuff working, we can merge the calibration stuff in OpenPilot. If you guys have any interest in that.
So you want zero copy from NumPy? Nimblegen, any reason that's hard?
From Qualcomm. I have an issue for it if someone wants to look at it. It's one of the latest Tinygrad issues. That's the last blocker on merging all that stuff.
Yeah, can you hear me? So yeah, probably that's easy. The only problem, I know, I'll try to do that to map NumPy memory for QCOM. I think that should be possible. Yeah.
Should be possible with zero copy, right? Because I mean, it worked with the OpenCL stuff, so I assume it should work. Yeah, if you need anything else from me on that issue, let me know.
Yeah, so it looks like it's just making from blob work on the QCOM backend.
Yeah, exactly.
Oh, cool. Yeah, so I think this is higher priority than HVecT code, but lower priority than any MI 350 issues.
Let's move on to Mesa backend.
So yeah, Chris is he can listen, but he can't talk in the meeting. So I can kind of fill in for that. Yeah, I mean the Mesa backend looks good. I think we'll get it merged probably this week. Yeah, I mean it's exciting that we'll have an open source Qualcomm backend. It's speed competitive with the Qualcomm closed source one. And I think maybe we can do a few small tweaks to it to get it to be better. But I think long term, the project here also is removing image from D types. Image should not be a D type. The only difference between image and buffer is the instruction that is used to do the load. So there's no difference even really on stores. There's no difference on anything except loads, because if you use the image instruction to do the load, there is a texture cache. And that texture cache is twice as fast as any other memory-ish looking thing on the Qualcomm GPU. So that's why we have to use it, but it's really just instead of having a load for instruction, you use the texture sample for. And texture sample also gives you this added benefit of it's two-dimensional. So it does this added benefit of doing the indexing math for 2 dimensions, and it also deals with overflows for you. But again, these are all optimizations that can be applied right at the end. These are not optimizations that have anything to do with what you have in tensor.py or dtypes.py. So that should all just be removed from there. And then I think we'll have a lot less bugs too. It can also silently fall back to buffer loads if for some reason it didn't fuse. It should just be a performance thing. It should not be like, I need to specify that this is an image thing. So
I think the potential blocker might be we have many places that try to maintain the image as an image. Otherwise, some other optimization would break it without aware there's a more later optimization that can make it fast.
yeah, so we probably have to do it before things like simplify valid and those kind of things. But regardless of like where we do it, at least it doesn't have to be in tensor.py. Even if we do it as like a pretty early rewrite, like even if we do it, I mean, probably the right place to do it is like post range. Like when you do the upcast, call it like image upcast or something.
Oh, you mean those path to forward and do a image conf thing should be removed?
So all the pad twos will stay, just the D type will go away. like the image com function in tensor will stay because the image com function in tensor is actually doing two things. And the other thing is an optimization we should work on as well, but it's doing the image d-type. It's also swizzling the data. So this was the biggest improvement on all the DSP stuff. The whole trick to the DSP is basically putting the data in a format that the DSP can read very quickly. So like imagine anytime you have like a global store and a global load, as long as you permute both sides of that, it's equivalent. So that's what the image conv and image gem code in tensor.py is doing. So we would leave it for that purpose. But all the places that we use dtypes dot image, we can change it.
Basically make image equals to 1 fast.
Yes, exactly. Yes.
Okay.
I mean that's the simplest way to put it. Yeah. So we would just actually start by making image equals 1 fast. Yeah, and then doing those rewrites on the back end silently. There's no disadvantage to using that image texture cache ever. So it's always a winning rewrite.
That sounds good. Next, I think Python speed. We got lots of things. I also remember you mentioned something about moving more stuff to the Python backend, building a queue and stuff like that.
Oh, I mean, when I was talking about moving stuff to the Python backend, I was just saying for things like zlib decode, we could put that on the Python backend, so then it would be lazy. These things are like they're not important really. But most of the Python speed stuff, the most egregious things have been dealt with now. The Rangeify is now pretty much back on par with what the old stuff was by adding a bunch of caches. There's the reshape cache and stuff now. I mean, Rangeify used to be brutally slow because the reshape would, like every reshape would be a separate thing. But I just wrote the substitute thing and it works. So yeah, you're hitting a reshape cache now. You're hitting a divmod cache. So there's a whole bunch of speedups there. I sped up the tensor map thing in tensor.py. The tensor map thing was n squared. I rewrote it to not be n squared. And between basically adding caches that match the old shape tracker view caches and fixing this n squared thing, the Python speed is like within the realm of reasonable now.
Cool.
So yeah, I'll definitely merge things to make it faster. So like we started off with stable diffusion. Like stable diffusion was taking like 50 seconds. Now it's down to 20 seconds. And I think with more work, we could get it down to 10. Yeah, I did like a little like micro optimization in the graph rewrite that adds like another 2% yesterday. I tried some bitfield stuff. It wasn't faster. I think now we're getting into the mostly the realm of diminishing returns, unless we find big bugs. But really, the way to improve Python speed is just to make the rewrites themselves, like just do less rewrites. What do we not need to do?
Oh yes, on that topic. How come? Oh, sorry. Before less rewrite, I don't see a huge change to Llama no JIT. Is it because we are doing too many rewrites?
Well, so for Llama no JIT, I guess no JIT, if you're not using variables, it's going to be slow no matter what. But like, I do want to write this schedule cache. So the schedule cache should be able to cache entire schedules, and that will give you like half of the JIT behavior for free.
Yeah, I understand.
Yeah. I don't know. I mean, that's one of my like. There's a whole bunch of refactors that can be done here. Like, I want to move more stuff to mixins, and like really make that code good. There's definitely a path now. It's nice how like everything is UOPS. UOPS are pure. I think that like the old scheduler, you couldn't touch it. The new scheduler, you can touch it. It all kind of behaves how you think it should. It's been a long time since I've hit something where I'm just like, I literally have no idea how to do this refactor. There's so many weird broken things. I think we're mostly past that now. And pretty much every time I'm like, oh, I want to refactor like, the pad op to not pad both sides. Okay, cool. That's going to take me an hour. Like that's not even, all that stuff kind of works now. So that's pretty good. But yeah, so I think that a lot of polish can be done by moving stuff to like mixins. And then once that's done, we can look at tensor.py and be like, oh yeah, now the schedule cache is like really easy to write. It's just like one little thing in there. And then also refactoring the JIT. The JIT right now confuses two concerns. It confuses this concern of capturing a function with applying the graph. So we have these graph things on GPUs, which are more like cached command buffers, but that really has nothing to do with the JIT. So we should separate out all the cache command buffer code. This gets into like the HCQ refactors. There's a lot of stuff that can be done there too. I think that a common feature that we get a lot of requests for is being able to really nicely export those things and play them back later, kind of what Commas Compile 3 is doing. Jay Suarez was asking for it, like just this idea that you can just export a JIT really nicely, not some weird pickle format. So yeah, we can get there. It's on the priority list, but yeah, we can decide where it is on the priority list.
Yeah. So another small thing to add is I was trying to simplify all the symbolic stuff, or I guess in general, a lot of the rewrites. There are hidden complexity about the order of things, and sometimes you need to add symbolic to device render extra matter. Sometimes you really don't, because sometimes you explicitly want something to not be rewrite. An example is, for example, for FP8 in AMD, if you do a FP8 cast, we really want it to be cast to float first, then to your whatever bflow 16 or something like that. So I think there are a lot of I try like swapping the order or change some rules here and there, and something would just subtly break, and that really is like impossible to maintain.
Yeah.
Something I hope I can. Basically, two things here. One is I root cause the issue with the conv that's not compatible with the very last Valley hack image thing. So that hopefully I will have some solution soon. Then another is I think we can better categorize these rules as some rules that strictly remove certain uops and return you something that's from its source. There are some rules that gives you maybe gives you a const at the end and nothing else. And there are rules just reassemble stuff. I think instead of saying this is simple, this is symbolic, and this is sim, having some understanding for like how to categorize lists will help. And eventually we can decide like in what stages you use which one, and is like some of these should always be safe to attach if you choose so, and some of these should be explicitly set. Say for example, your extra measure in the render. If you want to add some other symbolic rules, you specify there and not in the main cogen loop. Something like that. For now, people just like add another thing very freely, and which makes like your vector list pretty hard.
Yeah, I really like that idea. I think that our names are total nonsense. Symbolic, simple, symbolic. I know you could finally get rid of symbolic flat and then sim. Yeah, these names, yeah, these need to be named things like there's probably ChatGPT will probably come up with great names for like
So yeah, I think other framework MLIR has an idea for the strictly return your source. So basically strictly removing stuff. And they have one that's kind of give you a similar one, and another one that's like rearranging stuff basically. I think that's the idea.
Yeah, we also how much would egraphs help?
I don't know.
I mean, there's some stuff if you're struggling with stuff that like, oh, like different orders do different things.
So for now, I don't really struggle with ordering, but it's just for some device extra mature renderers, it kind of assumes you shouldn't do something to mess around with your rules, but because those assumptions are not explicitly set and a lot of time not even tested, the reason I found it is I try process replay, changing order, and see a diff in one of the kernel. So I think that's the hard part.
Yeah, I mean, I think that like the thing that you really want egrefs for is things like factorization. Like try like factoring and unfactoring things and seeing if you can get like things to match and things to cancel out.
Yeah.
But it's all a pretty simple addition on top of what we have. But you know, I mean, I really like this idea of like making a taxonomy of the symbolic rewrite rules and just moving some to like the You're right. This is only going to either remove things or replace things with a const. Like removes things, replaces things with a const, does other weird things.
Next, some ideas for assembler.
Yeah. So, you know, it's going to be a slow project. I posted that thing in announcements. I think it's like with this SQTT stuff, we're now working on the like the bottom and the top, and then there's this LVM in the middle, which kind of can ruin everything you did. Like it can make all these changes. So we do have to move to assembly. We have to remove LVM. I think RDNA 3 is the place to do it. We need to be able to tie each UOP to what runs on the GPU. So yeah, you know, it's going to be a slow process. I'm going to work on it maybe a day a week, 2 days a week for the next 3 months. And then we'll have some nice baseline assembler, disassembler. And then I also want it to be a cycle accurate emulator. So for each instruction, I don't just want to have a like how to transform this into a string and back to something else. I want to say what this actually does. So how it updates the VGPRs and stuff, but also how many cycles it takes and what GPU resources it uses. And we can validate all this with SQTT. So SQTT will show us when the instruction got dispatched and when the instruction actually ran. And these things are mostly pretty simple. I think it should be pretty easy to make like a little model of a GPU. Modeling the memory system is probably more difficult, but modeling the ALU should be pretty easy. And then we can like, know for this chunk of ALUs, okay, are there going to be stalls here or not? And LVM seems pretty unaware of a lot of this stuff. You can look at the code outputted by LVM, and there's ALU stalls, and they're just nonsense. Like just simple reorderings would fix it. So I think the best thing to do though is to not try to fix it. It's just to never emit code that does this. Like this gets into like what the devectorizer is, right? Like the devectorizer, the order of the devectorizer and how the devectorized stuff is emitted to assembly matters a ton for avoiding ALU stalls. So, yeah, the slow process of assembly, adding assembly. I think RDNA 3 is a good first target. It's documented. We know the most about it. We have a lot of it. It's a GPU. It's mostly what you want.
Okay. Sounds good. So I see B1 TG is here. You want to share something? Running on MI300X. I saw you hit the device end.
Yeah, I was still blocking by the GPU harms on MI350, and it also happened on the MI300. I posted the reproduce script in the MLPerf channel.
Nimmelgen, can you look at this? This is top priority. We need to get this stuff fixed.
Yeah.
Yeah, make sure.
I see
If you have any
error.
problems reproducing it, just let me know.
Yeah. I see the error screenshot, but I don't see the reproduce. Or
Just run the run the dev run message in the master branch. If the GPU numbers bigger than 1, it can trigger the bug.
Sounds good. And do you know if this is running AMD, right? Okay.
It's running AMD backend.
Mhm. So MI350, the same MMU fault, and third on MI300, this
Yeah,
hardware.
the error message in the message looks exactly the same.
I see. Okay.
And another thing I want to ask is there any way we can write a no grade in Tinygrad?
What do you mean by that?
Like because when I in the FP8 linear, I quantize the input and weight to FP8 and do the metamail.
Okay.
So in the backward function, I need to ignore the clamp and Amex to make it not infect the.
I think for now, if you want to ignore certain part of the autograd, it's probably better to use custom.
Yeah, now I just write a custom forward function and write a backward custom backward function to set the gradient to none.
I don't think we have. I don't think we have currently anything look like that. Basically,
So I need to write a custom function.
yeah. I think to start with, try it as a custom, and we can think about what this API should look like, because CAS is, especially for small D type, is weird. I think FBA, they sometimes also use different FBA for forward and backward because the scale is different. So for now, if the custom works, let's start with that. And if that doesn't work, just post the issue somewhere.
Okay. Also, the clan functions backward behavior not the same as touch. Clan clan function when clan function was become a max of in Tinygrad. So when it hits the edge value, the mean or the max value, it gives the gradient 0.5. But in touch, it's behavior difference.
I think for these,
Do we want to match the touch behavior?
I think generally yes. So for API returning different number or for its backward behaves differently, you don't need to wait until the meeting. You can just open the issue, and I think the idea is, unless Torch does something very weird that we don't want to copy, or the values or the backward behaviors we probably want to follow. So anytime we found a difference, is either we explicitly say we behave differently or it's a bug and we want to match.
Okay.
Cool. Yeah, these like half like the average of the two or the max of the two, because I think Torch's principle is to use subgradient. We are kind of ad hoc, so it's very possible that we don't write some of these sharp thing like matching the torch, and we probably should. So it's good that we are finding these. Okay. What else? I see Flemit. Flemit, you want to say something about your fast memo?
Yeah, I was just going to bring that up. I had to use a speaker, but you have to exit and re-enter if you want to talk.
Can you hear me?
Yes.
So there's a draft version of UOP generated max gem kernels. They're a little slower than the hand coded ones, and obviously the C style changes can't stay there. But surprisingly, it's correct and it works.
Yeah, I'm looking at your C style changes. What are they doing that you can't do with? Oh, you're using LD matrix.
Yeah, it doesn't need to use that obviously, but
It doesn't need to
that's
use
what
LD
the
matrix. Oh,
original
great.
code was. No, you can. I think you can issue four loads,
Great.
and it's equivalent.
I mean, it should definitely be the same thing. Cool. Yeah. I mean, the speeds on that look great. The testing you flipped around which one is FP32 ACC and which one is FP16 ACC. But
Oh,
yeah, I
cool.
mean, 309 is great. And that's the real one to test too, because that tests like whether you're real, like because NVIDIA throttles these things. The GPU is so over provisioned on the FP32 ACC, but on the FP16 ACC, getting over 300 is real.
Yeah, I mean you basically move a lot of that complexity just into generating the right UOP structure, the swizzling, but it renders properly. So that's a start.
Great. How have you found the UOP programming language?
The agents have helped more. So I'm
Oh.
only starting to understand what's going on.
I mean, like
That's
you're
why
doing a
I
lot of
recommend.
stuff. I see. I mean, when you write something like that, you don't have to write that. Like that's equivalent to just saying, like all of the beauty of Tinygrad should work in UOPS. Like you can just do that.
Right. Yeah. I mean, this is why this is a draft proof of concept. I was like trying to get it to pass the test.
Yeah.
And,
I'm glad it
nudge it
works
properly.
Yeah. No, and it's great that we can show that the like the linearizer and all the output stuff works. But yeah, no, I think there's a ton of cleanup to this, and I think it could be really good, and we could maybe even almost ship it.
Yeah. I mean, obviously doesn't use the linearizer, right?
Wait. Oh, it doesn't use a linearizer. Oh, you're just concatenating. You're just.
Yeah.
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 Any reason you can't use linearizer?
Well, I'm not sure. Again, I don't know.
I mean, it should
I don't know
work.
how the copy. I don't know how the async stuff with the pipe commits and the weights would get pushed up that far on all the pipelining. I just don't know.
It should mostly work. I think you'd be surprised how good the linearizer is, especially when we fix after end. Yeah, there's basically there's a function called after, and you have to use that. So after will like if you want to buffer after a store happened, you just do like buff dot after the store, and that promises you that the store happened before that buffer is returned to you. But yeah, that after should let you do all the pipelining stuff and all the async stuff too.
Yeah, sounds good. I mean, again, I just wanted to post it up there to see. It's like, yeah, it's doable. It's just a matter of starting to lift it higher in the stack.
That's good. Do you have anything to summarize for your discussion between the buffer guy?
Not particularly. I mean, he's complaining about the state of the documentation.
Yes.
Yeah, and the state of the error messages. I mean, those things aren't good. It's not 1.0 yet. He says a bunch of the kernels are faster, which is good. He wants aggregation in the profiler. Quaslin, I don't know what like other profilers have for this. If there's some like obvious features that like every profiler has that we don't, we should add them.
One thing is our profiler, I never understand when does the profiling stop. It gives me a very long timeline that I can scroll.
Our profiling never stops. What do you mean? Why do you want it to stop?
I just no, I mean the end of my program and the profiler starts, right? So how long does it take for my program to finish? Something like that?
What do you
Just
mean?
press space and you see the like whole graph.
Yeah, if you press space, it'll zoom to that.
Yeah, but you can zoom to everywhere you want. I don't want to limit you on that.
Yeah, I think being able to zoom forever on both sides is totally fine. I mean, it's the same as the graph, right? Like in theory, you can zoom out and make it super tiny.
Yeah.
But I'm not understanding. Like, is that what you mean? Or if you just hit space, the whatever the last thing, whatever the right side is there, that should be good.
Maybe I'll try this.
Yeah, I don't know about these aggregate timer results over many calls to the same kernel after warm up. I'm curious. I've never like seen that in the Torch profile. I've never used that in the Torch profiler either. I've just seen the Torch profiler show me all the steps. But yeah, I mean, if there's something obvious that we're missing. Yeah, and then the index set operations, like he's using like a normal experience replay buffer in RL. I think that's mostly what I'm going to work on this week. Which it's also the same stuff that we need for it's slice to sign basically. It's like making slice to sign good and not user realize, which I think we can do.
Okay. Sounds good. I think that's pretty much it for this meeting.
I like this though. Error messages in general are not super helpful. You tend to hit internals a lot. Not a deal breaker since Torch sucks worse in compile mode. So good. Yeah.
Yeah.
I mean, that's been my experience with Torch compile too. Like if it works, it's great, but if it doesn't work, good luck.
Sounds like Tinygraph.
No, Tinygrad is fixable. It's just the error message isn't what you want. Like Torch, you actually can't fix. Tinygrad, yes, you can't fix it in 5 minutes like you could if the error message was good, but you can fix it in an hour.
Yeah, I think we just have many stuff that currently is very hard for a user to fix. It might be relatively easy for dev to fix.
Yes. Yes. When I say an hour, you're going to have to look at the Tinygrad code. But when you look at the Tinygrad code, you can look at the Tinygrad code, which is try to understand how Torch compile works. Good luck. Yeah. Oh, I wouldn't have expected TF32 to have only been in MVARs. I don't know if we can do something about that. I mean, I think it's only in MVARs in Torch too. I don't know.
Still use TF32.
I mean,
Okay.
yeah, the TF32 thing. Oh, I guess one more thing. I want to get that that process replay thing merged. Did we ever get that merged? The sub actions?
No, there's like 3 other refactors that you have to do for that to
Well,
work.
one of those is the TF32, and I'd like
Yeah.
to fix that. Also device count.
Core ID still there?
Which one?
We still have core ID.
Core ID. Oh, core ID in the core ID in the C style. Yeah, that's got to go. That bothers me every time I see it, especially when I'm not using it. Yeah.
We just have 3 things that aren't reproducible, and those require refactors elsewhere. I tried doing TF32, I got bugs with like things wanting tensor core but not getting tensor core.
I see.
So yeah.
Well,
And for the compiler selection stuff, like we do that on init. So like if you set a context with CPU LLVM, it doesn't respect that, it just uses clank.
yeah, we have to fix that. Yeah. No, but they're all good refactors that we should make anyway, and they're all surfacing real bugs, so yeah. Whoever wants to take one of them. I could take the TF32 one. I know what to do for that one. CPU count, I don't know. Oh, cool.
Sounds good. I think that's it for this meeting.
Great.
December already.
Yeah, Advent of code.
Let's train Llama.
Let's chain Llama. End of the year. We're gonna have state-of-the-art flash attention on OA350, as promised.
Cool. Okay, thank you everyone. See you next week.
Bye.